My name is Mark Fink of Fink Management, Engineering, and Technology, and I'm changing things up again. This is episode 1 of TPOC Talk, discussions with technical points of contact. And my very first guest is a longtime friend, Dr. Richard Buchroeder. Hello, Dick.
Hello, Mark. Thanks for that lovely introduction.
Great. I do appreciate you participating in this experiment and going through this interview process. As interviews normally go, usually the host kind of reads over a resume, and let's just get the viewers familiar with a little bit of your background and history.
Okay.
Specifically, we have here, you have a BS from University of California, Berkeley, a BS in mechanical engineering specifically, an MS from the University of Rochester, a master's in optics, and a PhD in optical sciences from the University of Arizona.
Well, that's true.
That's true. You have over 40 years of optical design experience, working at places such as Bausch & Lomb, Hughes Aircraft, and then you became a small business owner. Your company's name was Optical Design Service, where you have a range of clients from nearly every major U.S. defense contractor to international optic companies and numerous U.S. universities. Most recent work was in dental and medical marketplace, and you're now supporting local astronomers. You are officially retired.
Yes.
Yes, officially retired. So not necessarily hunting for new business and looking for new customers, but you're also a holder of 13 U.S. patents. So even though you were consulting in a small business, you still got your name on some of the patents. So obviously very, very busy person, very smart individual.
Thank you, Mark.
In addition, I know in many podcasts, people have movies or books and stuff. I don't think you have any specific books, but let me show. There's a couple of things that came across my history with your name on them. One is, and now you're not going to find these on Amazon at all. I doubt you'll find them. But this book, this report, an optical analysis of the Farad VCAS helmet-mounted display. This was back in '83, October of '83. And then this one is a tutorial short course, and helmet-mounted displays. So obviously we're very busy, very interesting books, technical books. I'm sure a lot of technical people would fall asleep with them, but very rich with knowledge, insight, first order design stuff. So
that's true. There's also a number of publications you can get by looking up my name on the web.
In fact, one story I have when I was at Hughes was we were doing an interview with some up and coming people who wanted to join Hughes, and we were chatting. I was chatting with this one applicant, and we were mentioning, how did you get started, in your career and going to college? And then he asked me how I got started. And I mentioned a little bit, and then I said, hey, also one of the key aspects was I ran into this guy named Dick Buchroeder. And the guy almost flipped out. He went, Dick Buchroeder, oh my, you know who he is? I said, yes, he's a guy whose house I go over every Thursday night, and we have Burger King before we do some optical design. And the guy was he had read your articles in astronomy or wherever they were, so he knew very much of you from a technical aspect. I mostly know you just from the friendship that we've had and the abuse that you gave me when trying to learn optical design. So you are very well published, and I would imagine very well respected.
We'll see about that.
Anyway, is there anything that you want to add that I'm missing? Anything you want to comment on my short introduction about you?
Well, I might explain why I went from mechanical engineering into optics.
Well, why did you go into mechanical engineering?
Well, I like to take things apart. I always thought it was a lot of fun to take things apart and then try to put them back together again, make things work. I used to read Popular Mechanics, especially the telescope making section.
Uh-huh.
And so it just seemed like if I had to go into engineering, it would be easier than double E and more productive than civil. So I hope I don't offend too many of your readers.
I'm sure you did not, Dick.
So mechanical seemed like a very good thing to go into, and indeed it was. I'm very, very pleased with that background. It comes in handy even in optical engineering.
Okay. It does, definitely. My experience, No, in my experience, optics don't float in space. They have to metal. You have to wrap metal around them.
Wrap something around.
And that's very important as the optical engineer understands how these are going to be mounted and how they're going to be assembled. So it's a very important aspect. But you did say you transitioned from mechanical to optics.
Yeah, and the way I did that was when I was at the Berkeley, the University of California. They had a co-op work study program, which I got into after about a year. And that enabled me to get a job working for the Navy at China Lake.
Mm-hmm.
And I was in what amounted to an optics group, code 4056 for anybody who keeps track of numbers. And I had some bosses there, as well as I got a chance to see the guys in the optics shop.
Mm-hmm.
And I was always interested in amateur telescopes. So this really was a great introduction to what you could do if you had a degree in optics. My boss was I think he at least had a master's degree from Rochester, the University of Optics, Institute of Optics at Rochester. And so that made me think, gee, this is a lot more fun than going out and photographing airplanes dropping bombs.
Of course, yes, definitely.
My work at Knott's was basically on the aircraft field with taking photographs of the test equipment. And so I decided that when I graduated from Berkeley, I would go to the Institute of Optics in Rochester.
Mm-hmm. That's right. And then at Rochester, obviously you went for Rochester specifically for the optical degree.
Exactly.
And then was that a huge transition going from mechanical to optical? I mean, was it straightforward? Did it come naturally? I
think it was fairly easy, fairly natural. You have the same basic training in physics and things of that sort. And I particularly wanted to take classes from Rudolph Kingslake, the legendary Rudolph Kingslake,
mm-hmm.
Who was still teaching. And his laboratories are run by Bob Hopkins, also a legendary figure in optics. And I think that taking Kingslake's course had a tremendous influence on my skill as an optical designer. It helped me to visualize how optics worked. There's more to it than just math. There's an intuitive feeling that goes with creative optical design.
That's true. I remember we would joke, and especially in my early years as an optical designer, using code 5, just put some glass in there and hit auto go.
Yeah.
And more often than not, you ended in disaster.
Well, it just took longer to get something useful.
Right. So, you've always, you tried to ingrain in me, you need to get your first order stuff squared away, your F numbered, your NA, and you need to understand the glass choices that you're going to, the color correction you're trying to do.
I think that's exactly right. And it still would be true if one were an individual private consultant. But unfortunately, I don't think there are a whole lot of us private consultant type optical designers anymore. The automation in computers, especially for optical design, has become so creative and so powerful that we're almost obsolete. We old-time optical designers.
Old-time. That's right, because this is way before. So you were doing lens design essentially by hand, I would imagine, at Rochester.
Well, I got a job at Bausch & Lomb. When I went from California to Rochester, New York, I applied to Kodak and Bausch & Lomb, and I settled on Bausch & Lomb, which was a better choice for reasons we won't go into now. Yeah, and the computing there at first was done on mechanical calculators, Marchands and things of that sort. They finally let us use an IBM, very basic card punch reading computer. And so it required a lot of insight before you got too serious about running the computer. And that was very productive. Also, when I worked at Bausch & Lomb, I was there 4 years. I had the privilege of being around really experienced people in optics. And I think that also had a tremendous bearing on my later skills.
Mm-hmm.
What I did to get a master's degree at Rochester, I worked full-time at Bausch & Lomb, and a bunch of us went to the University of Rochester at night and on the weekends. And Bausch & Lomb paid for that. Kodak did likewise for their young engineers.
Mm-hmm.
And so I got a free master's degree in optics. It only took 4 years.
Wow, that was longer than mine. Mine was 3 years.
Mm-hmm.
They celebrated when I graduated, so they celebrate when you graduate.
I don't know if they had a party when I left or not. But I will say that my contacts at Rochester helped me get the job at the University of Arizona Optical Sciences Center.
Because that's where you went next to get your PhD.
That's where I went next.
Right.
Well, I didn't go there to get a PhD. I went there to get a job.
Oh, really?
And
At Optical Science?
At Optical Sciences as a research associate, which meant being an optical designer for projects that they had going.
Okay.
And it was referrals from Rochester, the academic referrals there that got me the job. Aiden Minell was the one who hired me.
Oh, okay.
And I forget exactly.
Who did you work for then? And who was your, if you were a research assistant, which lab? Or
research associate. I was just totally available to everybody. And when I started out, I didn't have any particular boss or supervisor because nobody else did lens design at the time.
Really?
Later on, Bob Shannon came in, and he was technically my boss for a while.
Okay.
But then I kind of drifted away and became independent again at the University of Arizona.
Mm-hmm.
And after 4 years, the people at Hughes Aircraft, which was in Tucson, Arizona,
yes,
became friends. And they made me an offer. They said, we'll pay you the same thing that they pay you at the university. We'll just pay you twice as often. So
okay.
I sold it.
Oh, yeah.
Sold out.
Oh, okay, same rate, but higher frequency. We'll do it. We'll do it.
Twice the frequency.
That works.
So I worked 3 years at Hughes Aircraft in Tucson. That's where I met Mark. It was met other nice people there too. A lot of good contacts.
Well, we met in 94, I think, is when you and I met. You would actually you were consulting when
once I left, I worked 4 years for Hughes, 72 to 75. And I went back to the university for another 4 years, again as a research associate.
Mm-hmm.
And that time I left when the money ran out.
When did you get your PhD then?
76.
And what do you remember the dissertation title or?
Yeah, Tilted Component Optics was the title, and that was under Roland Schack.
Oh, okay. Yeah, Schack is very well known in the optics community. Yes, he has, didn't he have a Nobel? Or
no, I don't know what he had, but he was probably one of the most highly respected American people in optics.
He was very smart.
Very smart.
I took some of his classes, and yes, I realized, I was not the smartest person in the room, definitely.
And that again was a wonderful deal because since I was an employee of the university, the PhD was for free. All it took was working day and night for 4 years.
4 years,
at least 4 years.
Well, that's fine though. I mean that's very interesting. So let me just kind of summarize here. So Berkeley mechanical engineering, you like taking things apart. But you were kind of got involved a little bit in optics and started understanding that. And at that time, the only place optics was being taught in any level of seriousness, Rochester, go to Rochester, get your master's, dabble a little bit with Ocean Long, get some experience, and then come to Tucson, going from snow-covered fields to desert cactus. And then, but it wasn't your intention to get your PhD here. You just
Not at all. Not at all. I was just sort of talked into that. They persuaded me that, hey, Dick, all you have to do is to work day and night for
4 years.
Number of years.
And then you get your PhD.
Yeah,
awesome. Well, that's good though. So then, so you got your PhD and then you're out doing your own thing in your company. And did you initially name it Optical Design Service?
Well, that's what it was. So that's what I
called it.
I'm not very creative in titles.
Well, your creativity is in lens design. So, I mean, you got to give up something.
Yes.
So
it has to give.
Something has to give. And then, how did you, I mean, so you're starting your business. How did you, other than university, I'm assuming, or Hughes being your first customers, were those essentially your first customers, or how did you grow your business to be able to?
Not Hughes Aircraft. Hughes Aircraft was mind your own business and worked for us. Mm-hmm. When I worked for the university, both my first tour, 4 years, and my second tour, 4 years, they were quite liberal as to what we could do in our free time, as long as it didn't impact our ability to do the work for them.
Okay.
And since I was surrounded by all kinds of creative people at the Optical Sciences Center in all different fields, they would do the favor of giving my name to somebody if somebody said, "Do you have an optical designer you can spare?" And that's how I got started. Referrals from the people that I worked with at the University of Arizona.
Okay.
And then later on, as after I left, after another 4 years, 8 years total at the university, and indeed it was because the money ran out, the contracts ran out. Once I went to work my customers, if they were pleased with my work, would give me referrals. And of course, if you don't get a good referral, that's the worst thing that can ever happen. So you got to be careful who you take on as customers.
Well, you took on good customers. You obviously were successful from the '70s all the way to
Almost the present.
the present.
Almost.
Almost the present. I remember in talking with you when we were working together, actually being mentored by you on optical design and stuff. You mentioned, about the same time, this in the mid '90s, ZMAX was just coming into into the market. So, and you mentioned and you told me ZMAX is one of the best things that made your business take off. What do you mean about that?
That is true. But let me precede that by saying that when I worked at Bausch & Lomb, they had a program. I forget what they called it at that time. I think Genie is what they called it. And then the people that wrote Genie for Bausch & Lomb branched off and formed a company called Genesee Computer.
Okay.
And they offered a program called Genie. They also offered a program by David Gray and some other software. And about that time, the first PCs were coming out. The first IBM PC came out. And that was also a godsend to us consultants, because up to that point, we had to pay by the second on Control Data Corporation remote terminals, which cost a fortune.
Yeah.
And so I got a copy of Genie, and I was good friends with the people that wrote it, and they could help me, and played with the Gray program for a while. And let's see, after that, some years later, a friend of mine said, "Hey, did you know this fellow named Ken Moore has written a piece of software, and it's almost free?" And I said, "Okay, let me get in touch with Ken." And I got a copy of that. And
that was the ZMAX.
That was ZMAX. And the ZMAX, I've used that mostly in the last 20 or 30 years, ever since it came out, in fact. And it was a very intuitive program to use, much better than the ACOS and Gray programs, which are highly weird.
Highly weird, okay.
Highly weird. It's all and very expensive to use. Mm-hmm. And so I used ZMAX for until present. I still have an obsolete copy of ZMAX, and I'm still able to do things as favors, mainly for the local astronomers here in Tucson and elsewhere.
Right, because I remember, I remember the conversation, since it was so cheap, and I'm thinking back when it started, it was like $300 in the mid '90s.
I forget, it was negligibly expensive compared to what I'd been spending on Control Data Corporation timeshare.
And I remember you saying, since it was so readily available, people were buying it, assuming they were capable of doing optical design, so they could just say auto go in the ZMAX language, and then they would realize that's not going to work, and they give you a call, right?
Well, it sometimes happens with all software and with all consultants. People get started because it's got to be easy, because this guy does it in a day.
Exactly, very easy, like trading stocks, building a house,
exactly.
or doing optical design, just straightforward, very easy.
But I don't think I got many jobs because of that. I think most of my customers were themselves not skilled in optics and needed somebody who was.
Okay.
And so if I got a good reference, they would hurry.
When I would always, in my experience, I would want customers to have the software. We would do the hard work, but sometimes, the customer needs to be able to pull open the software. They need to be able to, hey, I just need to be able to make a picture. I need to check something. I'm going to maybe change one component, and just look and see what happens to the optical system. So not doing really hardcore design, but they are able to maintain their project and go forward. So if I had ZMAX, I would then call you, Dick, hey, do this design. I need to decrease the F number. I need to increase DNA, do the hard work,
right?
Come back to me. And then I can then use the design, put stuff in, et cetera, right, to be able to communicate to my corporate bosses, hey, this is how the project's going.
I would say maybe a third of my customers fall into that category. The majority of my customers expected me to do the whole thing, including the artwork at the end.
Oh, wow. Okay.
So, which the artwork was usually more trouble than the optical design.
That's the PowerPoint engineering, which I excelled at, by the way. I excelled at PowerPoint engineering because I did not have to worry a lot of constraints with PowerPoint engineering. Um, so today, I mean, today, um, what do people need to do optical? I mean, we know you have your degree and there's schooling, but when you're doing optical design, what are the basic things that you need to have to start out? We already touched on it just a little bit, but what do you need? Say, Dick, here's a project. Here's your optical. I need an optical design from you. What do you need initially to start that process?
Well, I need to know the boundary constraints. How big and how expensive do you want it to be? How much less expensive than what I'd like to make it? And how good does it need to be? And what are you using to define goodness? Is there any compromise possible? In other words, if I can't do what you want, will you take what I can do? And so there'd be iterations of that sort.
Okay.
But basically, they would have a problem that was pretty well defined, and they would either have possibly done a lot of first-order optics themselves to see the feasibility of what they were asking for, and then they'd throw it over the wall, and they'd play with it for a while and get back to them and say, it's looking like this, what do you think? And they'd say, great, keep doing that, or, well, we can't do it, it's getting too big, or it's not sharp enough, and eventually, probably within a matter of a week or so, come up with a design. It's not like today where you've got a year to design a double Gauss, or I'd say double Gauss, a lens.
Yeah.
Back in the olden days, it was possible to come up with a pretty good solution very quickly.
Yeah, because now you have the requirements are harder. They're trying to go smaller. They're really trying to push the boundaries of what's capable, and it's challenging.
It is, yeah. And the software today has gotten much more sophisticated. I hate to, praise too many alternatives, but Don Dilworth's program used to be called Synopsys. I guess it still is, but then Code 5 also started using the name of Synopsys. Well, it's extremely creative, but it's still not trivial to use. It sort of falls into the category of old-fashioned software. You've got numbers and buttons to push, and it's not as automatic, in my opinion, as something like CMAX.
Okay, right. And then, and the other thing is you weren't working in a silo. It sounds like you were iterative. So you communicated with your customer, showed them things, got maybe some redirection. But from a small business guy, how did you control your costs? Because customers don't want to pay for extra work, but they're forcing you to do extra work. So how did you deal with that type of relationship or in a relationship?
Well, let's see. The question is, what do you charge a customer if you're a consultant? And I remember the director of optical sciences at one time said, you ought to figure out what you'd like to make in a year, and then divide by 3, and then use that as the basis for what you're going to charge a customer.
Okay.
So you basically charge 3 times as much as if you're working by the hour for a used aircraft.
Okay.
And that's what I did for a long time. How many hours would it take to do a job? Well, that's where your skill comes in, because if you don't know what you're doing, it can get out of hand pretty quickly.
Yes, definitely.
But generally, I would be willing to take a loss because I'm working for myself. I didn't have employees. And if I made a mistake, I'd pay for it in my own hours. And if I was good at estimating what it was going to cost, and I'd make more than the usual amount per hour. At one time, later in the game, my customers came to me and said, Dick, you're not charging tonight. I said, okay, we'll fix that.
Yeah, no problem.
No problem.
We'll take care of that.
Yeah. So sometimes you got to be careful. If you undercharge, that gives you a tainted reputation. They think you must not be very good if you're not charging as much as the other guys.
But did that eventually? In a competitive world, someone could be capable, but they're hungry and they try to underbid you. Did you ever have a problem with that type of competition?
I don't believe so. I think most people, when they finally got to me, decided that they wanted me to do the job for whatever reason. Maybe it's because that I was usually successful in a reasonable length of time.
Okay. Going back in your career, 40 years of projects and different optical design work, what was your most satisfying? Does one project stick out as, wow, that was an awesome, I wish I had, every project was like that? Does anything stick out like that?
No, I've had projects of all kinds. I've done underwater optics for Monterey Bay, and I've done a lot of astronomy optics for the big observatories, including the Gemini projects in Gemini South in South America someplace. I think what is it, an 8-meter telescope. Did the multi-conjugate adaptive optics for that. The design, those optics were made in Tucson eventually by another group of people. I enjoy doing things like that because it's the first time around, never been done before. I like things that are not repetitive. I would not like to design the 20th doublet in the world. That would be boring. I would charge extra for that.
I'm sure. But let me see.
Well, let me elaborate a little bit more.
Go ahead.
Here in Tucson, there's a lot of astronomy in Tucson. I've done work for Kip Peak at one time, but they've got their own people now. I've done a lot of work for the Catalina Sky Survey. Those are people that look for asteroids that are going to crash into the Earth. And there are a couple of telescopes on Mount Bigelow and also, I think, also on Catalina that I designed and they built in recent years. So those are very satisfying because it's local work amongst friends.
Okay.
And I nowadays when I do work, I do it just strictly as a favor. I don't want to get involved with the 1099s and sometimes.
Okay. But you also, I mean, you these books, head-mounted display and optics, eye optics and ocular things. You were involved in a lot of that in your early career. Did you find those?
Did a lot of work for the Air Force up in Dayton, Ohio. The Air Force Medical Research Group. Yeah.
Wright-Patterson?
Wright-Patterson.
Right.
And, in fact, I was working for Hughes once when we went up there in the middle of winter.
That was cold.
That was not only cold, but the airlines had lost my luggage and including my overcoat. So that was one of my earliest experiences with Wright-Patterson. But those guys kept me on for years. We did a lot of things.
Okay.
And those reports that you held up were basically a team project. I did optic design. They did write-ups, our work, so to speak.
Okay.
And as well as guidance as to what they wanted. And those were fun years. Did a lot of work for Wright-Patterson, ANRL.
Okay. And there's one project or a series or a specific design going, wow, I never want to see that ever again. Or I'm sure, or it's,
we built some things that didn't turn out well. Let's not do that again.
Well, if you've had a long engineering career, you've had things that, wow, that worked perfectly. And then you go, wow, that's just not going to fly at all.
So it's not that so much. It's just that some of that kind of work is not as much fun as a one-off new telescope or a one-off simulator or something that's really fun being what you enjoy doing rather than what they're paying you to do.
What do you see as the future? I know we've talked about this a little bit. We've chatted. But what are your thoughts about the future of optical design here in this country, the future of optical design in general? What are your opinions?
Well, all I know is I can buy some mighty fine optics that are made in the Orient. I'm just totally impressed with what they're doing, the prices they're selling for, and the quality that they're turning out. That's not technically a matter of optical design, although the photographic lenses are a matter of optical design, and they're doing things that we can't come close to duplicating. Multi-element zooms, multi-element, all kinds of things, 15, 20 elements. According to the background that I've had, you couldn't possibly tolerate something well enough to make it work. Well, or a optical research associate also has software that will let you take defective parts, put them together, and have the computer figure out how to best respace and retilt everything to make it work.
Interesting.
I expect they're doing that in the Orient too, because some of the things they're doing are just incredibly amazing. The number of elements and the finished optical performance is beyond belief. I would say that in the United States, most of what we see is work done for the military. And that has a different set of price constraints and time constraints. And as we've seen lately with rockets, some of the rockets we're building are just not competing with the free enterprise. SpaceX, for example, has just put a Boeing, United Lens, United rockets, whatever the guards, just can't seem to get their set to run on a regular basis. So there's something to be said for small groups, relatively small companies doing risky projects. When they succeed, they really take off and take over. So I don't know what the future, I don't know if I would recommend anybody become an independent optical design consultant anymore, because I don't think there's that much work available for the individual. Things are done by teams. For example, at Hughes, which is now Raytheon, they have groups of people there that are assigned to do this sort of thing along with other projects. So they do a lot of things besides just design the lenses. And, frankly, I would rather work for myself than work for a large company these days. And so there's something to be said about being your own boss.
Well, it is. I tried doing that myself, not very successful, but I did enjoy the team environment myself. I did enjoy working as a team, working obviously starting as an optical engineer myself, and then kind of migrating to a system engineer. I guess failed optical engineers become system engineers, and eventually they become program managers. So
Well, I would say it's probably not that difficult for anybody to become a passable optical designer because of the software we have now. But being a good system engineer is a different matter altogether. I can't even fathom the talent you have to do.
a lot of moving parts and thinking ahead of how you're going to test and how you're going to put it together. Actually, put it together first and then test it. But it all starts with good first order designs, as you have shown throughout your career. Any final thoughts, Dick, or any final thoughts of just in general?
In general, I would say that having a good background in mechanical engineering is definitely an asset to me, because I quite often end up going down to the optics shop, persuading opticians to continue working to get the tolerances, and also helping them put things together. And then when things didn't work, it was always the designer's blame.
Of course.
So I got quite good at actually getting hands-on experience of things, and that meant being able to adjust screws and knobs and see what was not working as well as it should have, what could be made to work without massive rework. So I would say if you were to go strictly to Rochester, you wouldn't have gotten enough knowledge. I don't think anyone needs to spend 4 years going to get a degree in mechanical engineering either, but melding the two would be a good thing.
Yeah, I think that's one thing I picked up from you and other people. The big thing is, doing the design, always imagine, are you going to really make the person putting this together really angry at you? And you do not want that guy come looking for you because it's really hard or the tolerances are just absolutely ridiculous. Let's try to think about how is this going to be assembled early on, how it's going to be tested early on. And it's really its own project by itself in parallel with the design effort.
I think you're right. One of my most fun jobs, though, did involve not taking no from an answer from the opticians. That's the optical system at Buchroeder in northern Arizona, which is a 60-inch diameter singlet made out of plate glass.
Okay.
The optics for that had to be made spherical, but they had to be made reasonably well. And the optical shop making it was in Texas, and those guys wanted to give up. I had to go down and visit them and hold their hands for a while and invest in. They could do it. They could actually show them how to do it.
Okay.
Which you wouldn't expect. But sometimes you have to know as much as the optics shop, if not more, so that they don't give up.
And that comes with experience and persistence.
And persistence and trust in what you're doing.
Sometimes the success is just rolling up your sleeves and diving into it and being persistent and not taking no for an answer. So.
Well put. Yeah. Well, do I ever take no for an answer? I guess if they told me to stop working on it, we're going to stop paying you, I would stop. I don't feel obliged to finish something unless it's being paid for.
Then that's true. So anyway, we're about out of time here, but Dick, unless actually there's you already did your final thoughts. So again, this was an experiment in interviewing a legend with some people. You're not really a legend to me, Dick. You're just a friend that I've known that works with me in optical design. I greatly appreciate the time to do this. Dick is retired. Kicking back, relaxing, enjoying the good life. But I do appreciate the time that you gave me to do this experiment.
My pleasure, Mark. It's been fun.
And I do want to also reach out. One of the things I would not have done this interview without the support, Dan Portick of BVS Film Productions, a very fine gentleman I met through a LinkedIn contact. And he's going to, I think the statement is putting lipstick on this experiment here to make it look presentable, so people can look at it and listen to some thoughts from a optical design legend in our time of technology. So thank you very much, and hopefully episode 2 will be coming up in the near future. We'll see. Thank you very much.
Bye, Mark.
Goodbye.